Okay, claim cards. Oh, okay. Okay. Everybody get the office hours up there?
Thank you.
All right. Oh, let me just say a couple things before we get started on this about your test. Okay, so the test is Friday, of course. Through 2.2, that includes 2.2, and includes the homework we're doing today. And there'll be 4 problems. 2 from the book, so 1 exercise, 1 theorem of some sort, for example, that was done in class, and then of course 2 new ones. Let me give you my usual advice. What you need to do is work problems. Okay, you need to work problems, and the best thing to do is to come up with your own practice test. And how do you do that? You open the book and you pick 4 things at random. Okay, 4 problems, especially picking ones that you're concerned about. Close your book, close your notes, sit down and work them. And if you forget a definition, like, f of a, or a is a set, then don't just immediately open your book or your notes and find it, but sit there and try to drag it out of your brain, because it's probably in there somewhere. By now it should be there. By now you should be able to write it down immediately, what f of set A is. But don't sit there trying to memorize it, because that's not going to help you. Remember, definitions in here aren't like definitions in a lot of other fields where, okay, they're a little fuzzy and all that, right? And you just kind of got to know what they are, right? And here they're exact. And that's both makes it more difficult, but it also makes it easier. Because if you understand the concept, then you should be able to write down the definition. And you may not write it down exactly the way it is in the text or exactly the way it's in here, but you'll write it down in a logically equivalent way, and that's just as good. All right? So, I know it's going to be hard to be disciplined to do this, but you've got to work problems. All right? And the definitions, if you don't know the definitions, if you don't know the theorems, then you're not going to be able to work those problems. And so you're already in trouble. All right? So, any questions about the test? I know some of you don't really have the definitions down yet, and that's got to change by Friday. It's got to change. If you're to be ready for the test, you should be able to pick any problem, any lemma, anything we did in class at random, and quickly write down a solution to it. Then you're ready. And then I predict you'll get them all. Okay? So, let's get started with the claim game. Let's see, I have one more card, 1 or 2 cards coming. One more card. And I'm going to just skip the first 2 because they were pretty easy anyway, and I want to make sure we get around to some of the harder problems. Just hand me your card for now and I'll shuffle through and see if you oh. I was going to say you can add some more on there, but okay, some of these are
1 and 2.
Some of these are 1 and 2s. I already see that some people didn't put them on there. So if you If you didn't specify, I'll assume that means you can do both. But in the future, it's much easier because James is going to be counting these, and if you don't want to get miscounted, you really should list them separately if they have separately numbered parts. Okay, so I'd like to start first of all with 15. And I'll go ahead and get somebody up there to do, let's just put 15 and 16 up there at about the same time. I hope you got that don't study on there. It's important advice.
Do you need any markers?
Oh, somebody gave me a, so Chris, this is gonna, well, okay. Anybody got a 3x5 card for Chris? All right, for the moment, I'm just going to put it in there blank, okay? And if the blank one comes up, I'll look at yours and see. Okay, so that was Chris. Oh, yeah, so Chris, do you remember which?
Yeah, you want me to fill it out again?
Yeah, just,
Okay.
yeah, okay. Anyway, I got a blank one for you in here now if you show up. And okay, so anyway, because we need to get started. Okay, so 15 and 16. Who we got? Philip. Why don't you do 15 and Jonathan Anderson for 16. Okay, so give you guys credit for your. Okay. Okay. Yeah, Jonathan, can you enlarge your font a little bit? Okay, at least for me anyway.
Can you read that, or?
Yeah, just, okay, yeah, but for the rest of it maybe. Oh. Oh, don't sit down.
Okay.
You get to say some things about it as soon as Philip gets done with his. So, Jonathan, while you're up there, part of this, I mean, you guys need to remember my other piece of advice, which is to be lazy. Okay, and so part of this you could be lazy on regarding what Philip is doing over there, and what part is that? No, don't, I'm just referring to your thing. He's actually doing something there that you could just refer to without redoing it here. It's not a big deal, but
That a squared equals, I guess I don't follow what you mean.
Well, one of the things that you proved,
Splitting.
yeah, I mean, it looks to me like you're reproving a squared bigger than 0 there.
Well, what I was doing was, oh, I'm sorry, that was meant to be. What was the goal?
But you've done it. I'm just saying that you're not being lazy enough with it, and right, because the 0 less than a squared is the previous problem that Philip's putting down.
Right.
So-
I wasn't sure if we had, shown, multiplying all parts of this. And so I broke it up into 2 parts.
Right, right.
And so then you use the 4 properties, we have to, I figured we had to just apply to that one, we can't apply to that one.
Right. I mean, there's nothing wrong with what you did. I'm just saying that the first one is sort of already given.
Okay.
I'm being really, really, really picky here, okay? And, accusing you of not being lazy enough and horrible things like that, right? So, okay. But yeah, so I'm just pointing out that first one is actually already done by the 0 less than a squared is already done by what Philip did. And you can multiply all the way across, right?
Right.
Because it's just an and statement. So there's nothing wrong with what you did, just that part of it was done in his section, and so you can always say, well, that was already, done earlier. Okay, you ready?
Yeah, sure.
Philip, I haven't, okay, so let's start with yours.
Okay, let's say we're proving that if a is not equal to 0, then a squared is greater than 0. So we have it's defined, it's not, I don't know if it's a 2.14, I think it's actually just like a limit that you gave us actually. Right beneath 2.14, the a squared equals a times a.
Does everybody understand what we're doing? By the way, somebody was wondering about the colon equals, and that's something that mathematicians stole from computer scientists. It used to be when you were defining variables and things, you used colon equal to define something. I don't know that that's still, I don't use modern programming languages, so, but anyway, so we stole it and hung on to it, and so that just means is defined equal to. That's just sort of shorthand. Even though I said defined, sometimes you'll say let and then use the colon equals, which means, let this be defined to be that. Okay? That's all that is. And so this was just, we don't know in here yet, remember you have to forget everything, what a squared actually means. And so here we're defining what it means. It means a times a. I mean, right? So, and then the point of this is to show something about a squared. Okay, so go ahead, Philip. Sorry to interrupt.
Through trichotomy, we know that since a is not equal to 0, a can only be greater than 0 or less than 0. So showing that's greater than 0, solve it out, and show a squared 0 is less than a squared. And we can do the same thing for a less than 0, but for that to work, it has to be greater than 0. So I made it negative and switched sign around. And I made it, you solve it out again, and it's still 0 is less than a squared. So that proves that a squared is greater than 0.
Right, and one thing I want to point out before I ask for questions of this, the minus a times minus a equals a squared, okay, that's pure field axioms, right? Because minus a times minus a is, minus 1 times minus 1 using things previously, right, times a, which is 1 times a squared. But again, that's field axiom stuff, so you don't need to do that at this point, right? So for example, if I gave you something like this on the test, I would probably say, you may use any facts that depend, any theorems that depend only on the field axioms and the order axioms or something along those lines, okay? And here, let's just sort through what he's using here, right? There are several things that come from the field axioms, right? Like 0 times a equals 0, okay? You should see that and remember that that's not an axiom, that you proved it, and you ought to be able to right now sit down, well, you are sitting down, but pull out your pen and write down a proof that 0 times a equals 0. And you should remember what's probably the most useful strategy for that, which is what? Uniqueness, right? So as you go through, even when you're working problems here, you can take a problem here and break it into pieces and probe into it and look at, well, what am I using here? And if you do that, it will really strengthen your understanding of this, right? Don't just do what you have here when you're, I almost said studying, when you're working for the test, right? break it down even further. Think about every single step. Think about how you prove each step, right? Because you could actually do this starting only with axioms, right? You could do that. You could start only with the axioms, field axioms, and the order axioms, and then prove the statement without using any theorems. Don't think I would quite go that far on the test, but you could do it, and it's a useful thing to do when you're preparing for the test. Okay, so now questions about what's up here. Sometimes students feel a little queasy about multiplying by minus a and preserving the inequality, right? But hey, minus a is positive, right? So no problem there. Okay, thank you, Philip. Okay, what about 16 now?
All right, so for 16, we wanted to show this, and so we have that and statement. I just broke up into 0 less than a and a is less than 1, and then you apply the multiplicative property by multiplying by, since a is greater than 0, you multiply by a of this one, you get 0 is less than a squared, and then you multiply by a again right here, you get a squared is less than a. I took that and statement,